Okay, today I want to talk about isotopes. So we started out by talking about ions, and what we mentioned in the other video was that ions came in two types. You have the metals, which will form cations. They do this by giving away their valence electrons. And then we have anions, and this is where nonmetals will take on additional electrons. Cations become positive because they have more protons than electrons. Anions become negative because they have more electrons than protons. We talked about the periodic table where we had 1 and 2, 3, 4, 5, 6, 7, 8 valence electrons. The transition metals will have 1 or 2, and the charges of these different groups, group 1 is a positive 1, group 2 is a positive 2. The transition metals will be a positive 1 or 2 because they mimic these first two groups. 13 is a positive 3, 15 is a negative 3, group 16 is a negative 2, they take on 2 additional electrons, and group 17 is going to be a negative 1 because they need to take on 1 more to have 8 electrons, and group 18 does not take on any additional, nor they give because they already have 8. Group 14 can be a positive 4 or a negative 4 because they can give or receive 4 valence electrons in order to have a complete octet of 8 electrons in the valence level. Going to isotopes. Now isotopes, it has a certain usage, and you have to think about your language arts skills here, because the definition of an isotope is going to be the representation of an element with variant mass numbers, and we'll talk about what that means in just a second. But know this, there are different isotopes for every atom. And when we want to name the isotope, we'll give it a name like carbon-14. We say the name of the element and the mass number. Now this mass number is a number of protons plus neutrons. It does not account for electrons. They do not contribute to the mass, so we'll leave those out of this number here. Let's start simple with the smallest element of all, hydrogen. Hydrogen typically forms this kind of atom with 1 proton and 1 electron. Most of the time there's no neutrons. Now, the way we want to write this and notate this is we have the elemental symbol, the atomic number, and the mass number. This is kind of upside down from the entry in the periodic table. We put the mass number on the top, the atomic number on the bottom. We could call this hydrogen 1, hydrogen 2, and hydrogen 3. But because they're so common, we give them special names. This is hydrogen, this is deuterium, this is tritium. So in this version, you can see that this has a mass number of 3 because there's 3 objects in the nucleus. 2 neutrons, 1 proton. But typically, it looks like this. But the idea is, we can say that these 2 are isotopes of hydrogen. If you just have 1, you'll typically just say this is an atom of hydrogen. But when you have 2 different kinds with different mass numbers, the way that you will use the word is you will say they are isotopes of hydrogen, or they are representations, different representations of a hydrogen atom. Here are some isotopes of carbon. We have carbon-12, carbon-13, carbon-14. Again, when you have a collection of different atoms of the same element with different mass numbers, 12, 13, and 14, what you can say is that they are isotopes of carbon. They're isotopes of each other. Carbon-12 has a total of 12 particles in the nucleus. Carbon-13 has 13. Carbon-14 has 14. Now, they will all have the same number of protons because every atom of carbon has 6 protons. That is the atomic number of carbon, and any atom that is carbon will always have 6. When we want to write the name, and we just talked about this, but I want to address it again, we have a certain way we have to notate it. We have the elemental symbol, and then we have A and Z. A is a mass number, and then Z is the protons, or the atomic number. So carbon-12 is going to have the 12 at top, carbon-13 has a 13 at top, carbon-14 has a 14 at top. This number on the bottom, again, is the atomic number, which we've already talked about, but is the number of protons. What I think is really cool about this is that when you write it this way, all you have to do is subtract, and when you do that, you'll have the number of neutrons. So what makes these different is the number of neutrons. Here, 12 minus 6 is 6, so there's 6 neutrons. For carbon 13, 13 minus 6 is 7, so there are 7 neutrons. And carbon 14, 14 minus 6 is 8, so there are 8 neutrons. And that's all there is to it. Again, going back, just know that the word isotope just means different example or different representation of atoms, and that you usually have to be comparing two that are different from each other to use the word isotope. Isotope is kind of synonymous with version. You could say this is a version of carbon, so you have 3 different versions of carbon represented here. You could say you have 3 different representations of carbon, but isotopes, each of these is an isotope of carbon, but you typically only use a word when you're comparing two. But again, just to know, the important thing here is that it's the name of the element with the mass number. Thank you for watching.